Section 2.6, our objective today is I can state and apply the theorems about angles supplementary to or complementary to congruent angles. So our first theorem today has to do with supplementary angles, and it says if two angles are supplementary or I should say supplements are supplements of congruent angles or the same angle, then the two angles are congruent. Okay, so what this is saying is that you have, say, angle 1 and angle 2. And then you have angle 3 and angle 4. Okay? So it's saying if angle 2 and angle 4 are congruent, then that must mean that measure of angle 1 and measure of angle 3 are equal, and therefore they are congruent also. Okay? So the given here is two angles are supplements of congruent angles. Okay, so that's our given. So given in terms of our picture is angle 1 and angle 2 are supplements, and angle 3 and angle 4 are supplementary. Okay? And they're supplements of congruent angles, so in our picture, angle 2 is congruent to angle 4. Okay? And what we want to prove is that angle 1 is congruent to angle 3. Alright? So we're going to, this is the first actual theorem that we're going to prove. Okay? And so number 1, our given is that angle 1 and angle 2 are supplementary, and angle 3 and angle 4 are supplementary, and angle 2 is congruent to angle 4. So all that is given. Okay? So the fact that two angles are supplementary, what does supplementary mean? Well, it means that the two angles added together equal 180 degrees. So we can say then measure of angle 1 plus measure of angle 2 equals 180, and measure of angle 3 plus measure of angle 4 equals 180. And we were able to say that by definition of supplementary angles. Okay, that's why we're able to say that. Now we can say that measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 4. And why can we say that? Well, in line 2, they're both equal to 180, so we can substitute. So this is substitution. Okay? And then in line 4, in the given, we are told that angle 2 is congruent to angle 4. And so since they're congruent, that means that they have equal measure. So we can say measure of angle 2 equals measure of angle 4. And that's by definition of congruence. And now we can subtract, get back my good pen here, angle 2 from this side and angle 4 from this side. So that leaves us measure of angle 1 equals measure of angle 3. And that was by subtraction property. And now technically we should also say that because they're equal, then angle 1 is congruent to angle 3. And then again, that's definition of congruence. Right. So, now the theorem also says, or the same angle. So that situation would be something like this. So we have this angle and this angle, and then we have this angle. So this is, say, angle 5, 6, and 7. So 5 and 6 are supplements to each other. 6 and 7 are supplements to each other. And so in place of 2 and 4, we would just put angle 6, and it would be the same proof. Okay? All right, then we have the same type of thing. Our second theorem is about complementary angles. Okay? And it says if two angles are complements of congruent angles or the same angle, then the angles are congruent. So basically this is the same as the first, except for now we're talking about complementary. So remember, definition of complementary is two angles that add up to 90 degrees. So this is angle 1 and angle 2. Oops. I keep wanting to do supplementary, I'm sorry. So there's angle 1 and angle 2. Angle 3 and angle 4. So in this one, angle 2 is congruent to angle 4. Okay? So the theorem says if angle 1 and angle 2 are complements and angle 3 and angle 4 are complements and angle 2 is congruent to angle 4, then angle 1 must be congruent to angle 3. And the proof would be exactly the same as the one for the supplementary angles, except for we would say at the beginning that measure of angle 1 plus measure of angle 2 equals 90 degrees instead of 180 by definition of complementary angles. But it's the same idea. Okay? So these two theorems are very important. They are used extensively. So this one we use very, very often. and this one we use very, very often. So you want to make sure that you have these memorized. Okay. Now let's look at some examples where we might use this. Okay. So example 1. Given that ray BD bisects angle ABE, and I want to prove that angle 2 is congruent to angle 4. And here's my picture. Let me move this up a little bit. Okay, so my picture looks like this. This is point A, this is point C, this is point B, and then I have line BD, and I have line BE, and I have angle 1, 2, 3, and 4. Okay? So, okay, so first of all, they tell me that ray BD bisects angle ABE. Okay, so in my picture, here's ray BD, and here is angle ABE. So number 1, ray BD bisects angle ABE. And I can say that because it's given. Okay? Well, because this bisects, what do I know for sure about the picture? Okay? What do I know for sure? Well, by definition of bisector, it divides the angle into 2 equal angles. So I know angle 1 and angle 2 are equal to each other. Okay? So I can say angle 1 is congruent to angle 2. And that's by definition of angle bisector. Okay, that's how I was able to conclude that. Okay? Then notice also in the picture that you have this line and you have this line, which form vertical angles 1 and 4. And what do we know about vertical angles? Well, we know they're congruent, and I need to introduce angle 4 into the statement column because I'm trying to get angle 4 in there to prove. So I can say angle 1 is congruent to angle 4 by the vertical angle theorem, or just saying vertical angles are congruent. Okay? All right. Then I can show that I can say now that angle 2 is congruent to angle 4 by combining line 3 and line 2 and using substitution. Okay? So I have proved that angle 2 is congruent to angle 4. Okay? And notice that it all started by the given, and from the given I was able to determine something about the picture. And then I noticed that I had to get this in here in the statement column somehow. So I used a theorem that said something true about the picture, that angle 1 was congruent to angle 4. And then I was able to use substitution. Right, let's do example 2. Given measure of angle 1 equals measure of angle 2, I want to prove that angle 4 is supplementary to angle 5. Okay? And what I have is, in my picture, is 3 lines that intersect. And this is angle 1, angle 2, angle 4, angle 3, and angle 5. Okay, so right, so I want to show that angle 4 is supplementary to angle 5. Okay, so if angle 4 is supplementary to angle 5, then I have to know something about angle 2, relate angle 2 somehow to angle 5. Okay, so first of all, we know measure of angle 1 equals measure of angle 2. Okay, and we know that because it's given. Okay, then somehow I need to introduce angle 5 into the statement column. And looking at the picture, I see that angle 1 and angle 5 are vertical angles. So I can say that measure of angle 1 equals measure of angle 5. Okay? Because of vertical angle theorem. Okay? So now I can say, using line 1 and line 2, because remember I'm trying to get angle 5 related to angle 2, because angle 2 is supplement to angle 4. Okay, and that's where I'm headed for. I need 4 to be supplement to 5. So I can say measure of angle 2 equals measure of angle 5. And that was by substitution. Okay, so now I have those 3 angles congruent. And now I need to introduce angle 4, because I don't have an angle 4 in here. But I know that angle 2 and angle 4 form a straight angle, and so I know that it has to equal 180 degrees. So I can say measure of angle 2 plus measure of angle 4 equals 180. And that's the angle addition postulate. Okay? But in place of this 2, I can substitute measure of angle 5. So measure of angle 5 plus measure of angle 4 equals 180. And I use substitution. Okay. And then I can say angle 4 is supplementary to angle 5, and that's by definition of supplementary angles.